Anyway, let's continue. Working with radians. How many radians are in 90 degrees? 90 degrees. This should be an easy conversion back and forth. And for my students in calculus, I do expect them to know this measurement conversion fairly easily. So let's see. How many radians are in 90 degrees? This could be intuitively by knowing that there is 180 degrees in pi radians. Well, we are interested in 90 degrees. Well, let's divide this by 2, divide this by 2, and it turns out that 90 degrees is equal to pi over 2 radians. Ta-da! Or you could have followed a geometric approach. Some students are visual, and this is more visual for them. If we know that a full rotation here, 180 degrees, is equal to pi radians, well, let's go only 90 degrees. That means that we're going from here only until here. So that means that 90 degrees is equivalent to me saying pi over 2 radians. This is the angle. Remember, both measure the same thing, the angle. It's an angular measurement. This is the arc measurement. This is the angular measurement. They are related very nicely, okay? But we'll talk about that later. So let's do this one then. How many degrees are in pi over 3 radians? Remember, you can follow 2 approaches. So at this moment, either let the video continue playing and then rewind, or pause it and try to follow the 2 approaches. Follow the algebraic approach and follow the geometric approach. So I will sing for you if you decide to let it continue playing. Bum 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 bum. Bum 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 bum. Interior designer alligator. Interior designer alligator. Interior designer alligator. Interior designer alligator. Alrighty, you should be done by now. Bum 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 bum. Let's see, 180 radians. So we're interested in pi over 3 radians. We already know that 180 degrees is equal to pi radians. Well, then 180 degrees divided pi radians. Let's divide by 3, and it turns out that 60 degrees is equal to pi over 3 radians. Here we go, another key measurement. All right, if you would have followed the geometric approach with a circle, we say that here was pi over 2, here was pi radians. When we're interested in pi over 3, that means a third. Pi times over 1 times a third is pi over 3. So that means of a pi, this is where my confusion came in high school a lot. Every time that I thought of a pi, I thought of a whole circular pi. No, this is a pi in terms of radians. So this whole piece that is a pi measurement, let's divide it into 3. Maybe here and here. Do we know how many degrees that is? If 180 divided into 3 is equal to 60, and 60. So what do we know from this one? The 60 degrees is equal to pi over 3 radians. All right, so this little measurement right here, this little angle, you can tell me, oh, I'm sorry, this little angle, you can tell me that it's either 60 degrees or that it is pi over 3 radians. And get ready, because Mr. P is going to be using this conversion fairly easy, or the pi over 2 value easily, or the pi, or these ones here. These ones are interesting for some students. These ones, I don't know. These ones, I kind of lose a little bit of hope even with myself. But this measurement here should be key to remember. The measurements, all these ones, you need to know for sure 100% back and forth. 45 degrees, 60 degrees, and 30 degrees, and 90 degrees. Also keep going, this one. So this is the part that we use mostly a lot, but this is also necessary. All right, so let's move on to the next part. Ooh, this is an interesting problem. I want you to find the length of the arc intercepted by a central angle of half radians in a circle of radius 5. What is this even asking? Well, here, I show you. It's saying that we have a circle and the radius happens to be 5. All right, so it's saying, well, half the radians. Well, first, let me see what a radian looks like, right? If this is 5, let me start counting until I actually measure 5. And remember, I'm not going in a straight line, I'm going along a circle. So let's say this is 5. Well, then this is my central angle, theta. All right. And I formed a radian for this particular circle of radius 5. Right, and this is 5 also because it's a radius. So together they are radii. Interesting. Let's see. Again, let's continue. So it's saying, so they want you to actually find this length. And what is this length? This length is a whole radian. So central angle of a whole radian. So this angle is a whole radian, all right? So let's see, what is the length of this part of the arc that we get if we cut this central angle in only half? All right, so the way that I picture it in my mind, it might be a little bit different. This is the visual way. If this is a whole radian, all right, what does half of a radian looks like? Well, let me just cut the piece in half, right? This is my half my radian. This reminds me of pizza. I'm getting hungry, guys. This is my half a radian, and what is left? Well, the other half left off is here and here. So just by looking at that, if we knew that this whole thing was 5, what if the measurement now of the arc, that is by half a radian, if this was the whole radian? Well, the answer intuitively would be 2.5. So that's how I see it. The way that a lot of students see it and prefer to see it, I'm just giving you a little glimpse of what goes in my mind a lot. A lot of the students see it this way. If this is my radian that I just formed with a radius of 5, and this is 5. Well, this is the length of a radian, all right? There is this 360 around, and no, I'm sorry. Remember how many radians are around? There's around 6 point something radians, all right? 2 pi, each pi is 3.14, so that's the amount that is around. So let's see. Now, if they want half, a lot of students will see it this way instead. They take only halfway. Ta-da! Okay, so if the whole thing was 5, this is 2.5 and this is 2.5 as well. So we get the exact same answer.